Welcome to this masterclass on the applied science of cleaning chemistry. This is a premium professional training curriculum designed specifically for industry professionals, facility managers, and operations supervisors. Today, we are fundamentally elevating operational hygiene from what a lot of people incorrectly assume is just a basic manual chore into what it truly is, a precise, highly controlled science. When you truly understand the underlying chemistry of cleaning, you gain the power to drastically improve performance, protect critical surfaces, slash unnecessary costs, and, absolutely most importantly, guarantee the safety of your entire workforce.
Here is our curriculum for today's masterclass. We'll start with the chemistry of cleaning, move into chemical types and functions, cover precision dilution protocols, tackle hazard, risk, and safety, and wrap up with safety data sheets. Let's dive right in.
Section 1. The chemistry of cleaning. We need to begin right at the microscopic level to establish a core professional principle. Cleaning is not simply wiping away dirt. It's really not. When a professional removes heavy grease from a commercial kitchen floor or dissolves thick mineral deposits from a restroom fixture, they aren't just scrubbing hard with elbow grease, they are actively initiating highly specific, targeted chemical reactions to achieve a very specific operational outcome. Every single soil type requires an exact chemical counterpart to break its bond with a surface. Now, the absolute engine driving any detergent you use is the surfactant, which literally stands for surface active agent. Think of the surfactant molecule as having a split personality. It features a hydrophobic or water-hating tail that aggressively seeks out and attaches itself to soils and grease. On the exact opposite end is a hydrophilic or water-loving head. When you get enough of these molecules together, they form these incredible structures called micelles. The tails completely surround the soil, and the heads, attracted to the water, physically pull that trapped soil right off the surface, suspending it in your cleaning solution so it can be safely washed away. But here's where it gets highly tactical. Understanding the electrical charge of that surfactant's hydrophilic head completely dictates its operational use in the field. Anionic surfactants carry a negative charge. They are high-foaming and incredibly effective at lifting particulate soils like dirt, which is why you see them so often in standard soaps. Non-ionic surfactants, on the other hand, have a neutral charge. They're low-foaming and vastly superior at emulsifying oily soils. They also have this really unique characteristic called a cloud point, which is a specific temperature where they reach their absolute optimal detergency. Finally, you have cationic surfactants, carrying a positive charge. Because this positive charge actually disrupts the cell walls of microorganisms, cationic surfactants act as highly potent antimicrobial agents. In fact, they frequently form the active base in the commercial disinfectants you use every day. Okay, so what happens if the water you are using to clean is hard? Well, this brings us to chelating agents. Derived from the Greek word for claw, these act as specialized chemical shields. You see, if you use a standard surfactant in hard water, the minerals, like calcium and magnesium, will instantly bind to your surfactant, completely neutralizing its cleaning power before it even does anything. Chelating agents act as molecular claws. They actively hunt down and isolate those hard water minerals, altering their charge so your primary surfactants are perfectly protected and ready to attack the targeted soil. Moving on to Section 2, Chemical Types and Functions. With those microscopic foundations established, we need to systematically classify our chemical inventory based on its primary operational functions. And the single most critical operational distinction any professional must make is understanding the hard functional divide between detergents and disinfectants. Detergents utilize the surfactants we just discussed to physically remove soil, oils, and dirt from a surface. They clean, yes, but they do not necessarily kill germs. Disinfectants, however, utilize aggressive antimicrobial agents like sodium hypochlorite, which is your standard bleach, or quaternary ammonium compounds, commonly known as quats, to chemically destroy and deactivate pathogens. To achieve true professional-grade hygiene, these must be used in a highly specific sequence. You clean first with a detergent to remove the physical barrier of dirt, and only then do you apply your disinfectant to terminate the exposed pathogens. Leveraging the pH scale allows professionals to precisely match the chemical weapon to the contaminant. Acidic cleaners, those falling between 0 and 6 on the scale, are your go-to for inorganic soils. We're talking mineral scale, hard water stains, and rust. Conversely, alkaline cleaners, which range from 8 up to 14, are strategically deployed against organic soils. This means your heavy industrial grease, oils, and protein-based dirt. And for safe daily maintenance on unsoiled general surfaces, you utilize neutral cleaners sitting perfectly at pH 7 to prevent any surface degradation over time. Section 3, Precision Dilution Protocols. Now, understanding chemical classifications is only step one. The masterclass standard demands precise execution, because without exact precision dilution, even the perfect chemical instantly becomes an operational liability. This rigorous six-step standard operating procedure is what protects both your workforce and your facility. You read the exact labels, you measure accurately with graduated tools, and then we arrive at step 3, which is absolutely critical. You must always, without exception, add water to your container first before adding the chemical concentrate. If you pour water directly into a pool of concentrated chemicals, that reaction can cause hazardous, concentrated splashback and immediate dangerous vapor release. It's a massive safety risk. So add water first, then your chemical concentrate, mix it thoroughly, meticulously label your secondary containers to comply with OSHA standards, and store it safely. Let's look closely at the math here. Standardizing your operational dilution ratios is the only way to ensure chemical efficacy. If a solution is too weak, it simply is not going to clean, period. But if a solution is too strong, which is a shockingly common mistake made by untrained staff who assume more is better, it leaves behind a sticky chemical residue that actually attracts secondary dirt, damages your surfaces, and drastically inflates your operational budget through sheer avoidable waste. By strictly standardizing these ratios, you are guaranteeing consistent results and rigorous cost control. Section 4, Hazard, Risk, and Safety. Transitioning over to risk management, we have to critically address the severe physical consequences of improper chemical handling. Because when we are dealing with concentrated chemistry, the stakes are incredibly high. A masterclass professional fundamentally understands the critical difference between a hazard and a risk. The hazard of a chemical is its inherent, totally unchangeable ability to cause harm. Hydrochloric acid, for instance, is inherently hazardous and corrosive. You cannot change that fact. Risk, however, is the actual likelihood of that harm occurring. Risk is a variable, and it is entirely within your control. You actively manage risk through strict exposure limits, executing those correct dilution protocols we just covered, and mandating the proper personal protective equipment. Which brings us to the cardinal, totally non-negotiable rule of chemical safety. Never, ever mix incompatible agents. The most common, and arguably most lethal example is combining bleach with ammonia or any acidic cleaner. Doing so instantly produces chloramine gas or chlorine gas. These are highly toxic vapors that can cause severe respiratory damage or even death literally within minutes. Your staff must understand unequivocally that chemical formulations are closed systems. They are never to be subjected to improvised mixing. To properly mitigate these risks, your baseline organizational defensive strategy has to include strict protocols. You must always verify proper ventilation to prevent any hazardous vapor buildup. You absolutely must mandate the use of prescribed PPE, gloves, goggles, masks. Furthermore, unless specifically instructed by the manufacturer, you should only use cool or room temperature water for dilution. Why? Because hot water can rapidly degrade active ingredients and prematurely release dangerous chemical fumes. Never use metal containers for acidic cleaners to prevent rapid corrosion, and ensure every single team member is rigorously and repeatedly trained on emergency spill containment procedures. Finally, Section 5, Safety Data Sheets. To formalize, systemize, and legally anchor all of these defensive strategies, we rely entirely on the mandated blueprint for workplace chemical safety, the Safety Data Sheet. Required by OSHA's Hazard Communication Standards, the Modern Safety Data Sheet, or SDS, utilizes a highly consistent, globally standardized 16-section format. This guarantees that critical handling, hazard, and emergency information is accurately communicated straight from the chemical manufacturer directly to the end users operating in your facility. There is absolutely no guesswork allowed here. The exact scientific and safety parameters are documented right on this sheet. Facility managers, operations supervisors, and everyday users must be intimately familiar with navigating these exact documents. Now, while all 16 sections are critical to a facility's safety, professionals need to rely extremely heavily on Section 2 for immediate hazard identification and warnings, Section 4 for rapid first aid measures in the event of an exposure, and Section 8, which dictates the precise exposure controls and the exact personal protective equipment legally required to safely handle that specific substance. So, we have covered the molecular function of surfactants, the operational divide between detergents and disinfectants, the exact mathematics of precision dilution, and the rigorous safety frameworks required for true compliance. As you take these frameworks back and implement them within your own organizations, ask yourself this. If you continue to ignore the profound chemistry underlying these daily processes, exactly how much efficiency, safety, and operational excellence are you actively sacrificing? Mastering cleaning is never achieved by simply buying products. It's achieved by understanding the underlying science, deeply respecting the hazards, and executing your protocols with absolute professional precision. Thank you for joining this masterclass. Take these core principles, apply them, and elevate your operational standards today.